Section 1.8 is on simplifying algebraic expressions. Before we can actually get to the problems, we've got to look at some different terminology that we'll be seeing throughout the semester. Some words really that I've already been using here and there in the class. The first one is for a term. The definition is that a term is a number, a variable, or the product of a number and variables. Okay, so if we say that a term is a number, it could just be a number like 10 by itself. That's considered to be a term. Or a variable. Okay, so x by itself is a term. It says, or the product of a number and variables. So if I look at, it could be something like 2 times x. Okay, that would be considered to be a term because it's a product of a number with a variable. It doesn't have to have just one variable though. We could have something like -5, x squared, y to the 5th, z. All of that is considered to be one term because it's a product of a number with variables. You don't see an addition sign or a subtraction sign separating any of these. So as long as that's the case, then you have a term. Every variable term has what we call a numerical coefficient, and we typically just shorten this and say that it's the coefficient, okay, of a term is the numerical factor. This is the number that's in front of the variable. So if I have the term 2x, then I say its coefficient is just the number 2, the number that's in front of the variable. In my term above, -5x squared, y to the 5th, z, my coefficient would be -5. So you keep the sign with your number. If you have just the number like we had here, 10, well, it doesn't have a variable, so therefore it doesn't have a coefficient. Okay, this just goes for variable terms. Terms like 10 that are numbers are what we call constants. Okay, so here I have the term 8 does not contain a variable, and therefore it doesn't have a coefficient. This type of term is referred to as a constant, so you may hear me say that sometimes. Something else that's real important to remember is if we have the term -y, this actually means -1y, and so the coefficient is -1. So if I have a term, just a variable by itself like z, this actually means 1z. There's an understood 1 that's in front of that variable, and so the coefficient of it is 1. Okay, when we have terms that have the same variables in them, this is what we call like terms. So like terms are terms with the same variables raised to exactly the same powers. So some examples that we have of like terms could be like 5x and 2x. They both have just an x term. Or 3xy and -7yx. Okay, they're not written in the same order. This one has xy, this one has yx, but they're raised to the same power and they both contain those same variables. It doesn't have to be written in the same order. Now, we typically write it, xy, because we like to put it in alphabetical order. So these are examples of like terms. Terms that are not like terms are what we call unlike. Okay, so here's some examples of unlike terms, 2xy and 5y. Well, they both have y, but they don't both have x, so therefore they're not like terms. 6x squared and 8x, they both have x, but one has x to the 2nd, and one has just understood x to the 1st. So these are not like terms because they're not raised to exactly the same powers. So what you're going to have to do on some of the problems is just look at the terms and tell whether or not they are alike. The helpful hint at the bottom of the page is what I was talking about as far as the order. It says in like terms, each variable and its exponent must match exactly, but these factors don't have to be in the same order. For example, 2x squared y and 3yx squared. they are like terms because they have these same variables raised to exactly these same powers. So in part 2, we're going to be looking at some problems that we're going to work out with these.